Have you ever noticed squirrels scurried around campus and wondered if they followed a daily routine? At Georgia Tech, we did too. Every day we passed by squirrels chasing each other, climbing trees, or snacking on something they probably stole. But it got us thinking, is there a certain time of day they're most active? This simple question opened the door to a broader look at urban wildlife behavior. Understanding when squirrels are most active can tell us a lot about how animals adapt to city life, from avoiding heat to human disturbances to managing their energy throughout the day. That led us to our central question. Are squirrels more active in the morning or in the afternoon? What might seem like a small detail actually reflects how animals interact with urban environments, climate patterns, and ecological stressors. The goal of our study was to test whether squirrel presence differed between the morning and the afternoon on Georgia Tech's campus during spring. We hypothesized that the squirrels would be more present in the morning when temperatures were cooler and the campus is less active. Hello, my name is Kim, and this is our behavior project. For the methods, I analyzed squirrel observation data from spring 2024 and spring 2025, collected by students in our ecology lab. Each entry included the time and whether the squirrel was present. The day was divided into two windows, morning and afternoon, morning being 4 a.m. to 12 p.m. and afternoon being 12 p.m. to 5 p.m. Then we used the data and ran bar graphs and used a chi-square test to see if the time of day had a significant effect. Here we have two bar graphs, and these were ultimately rejected because I forgot to factor in the fact that these are just all observations, including the NAs. So then I had to rework things, and I got some viable data, and as you can see, it has way less of a count and takes into account the time of day, afternoon and morning, and if it's present, yes or no. Then I created a combined presence table, which has all the information in the bar graph. I just needed that to show, and ran a chi-square test, which I found the p-value was below 0.05, being 0.002979, which means that my hypothesis is correct and our null hypothesis can be rejected. As for our ecology and literature connections, I found one article which spoke about the patterns of both fox squirrels and the gray squirrels combined. And in this, it shows that in fact, for the spring, the squirrels were most active during around 6 a.m. In this article, we find that their data indicates that squirrels forage most actively in the morning. Foraging activity tends to decline in the afternoon, likely due to higher temperatures, as squirrels appear to prefer foraging in cooler, low to moderate temperatures. For my third connection, in an article, I found that nature conservation, as defined by the Cambridge Dictionary, is the protection of animals, plants, and natural areas and interesting and important structures and buildings, especially from damaging effects of human activity. This concept holds increasing relevance today, as natural environments are often overlooked in favor of capital-driven economic growth, resource extraction, and land development. So, why does this matter? Knowing how animals like squirrels adapt to urban life can help inform green space planning, noise pollution management, and climate resilience. Our study touches on ecology, animal behavior, and environmental adaptation, and connects directly to real-world challenges. So, what do we learn? At Georgia Tech, squirrels are definitely early risers, and that behavior isn't random. It's shaped by ecological patterns and urban pressures. Studying something as simple as squirrel timing reveals the big picture connections between wildlife and the world as we shape around them.